All right, guys, I guess it's finally time. We're going to start working on a Twitter contract. So the first thing that I want to do is I want to set up users and user authentication. So in the Solidity true Ethereum fashion, we'll create a user struct and we will let the user log in or sign up with their Ethereum wallet. So let me create the user struct, and what I need here is string name to get the name of the user. I want to have the wallet address. So let me store the Ethereum wallet. So basically address, like I said, it's a data type on Ethereum. So we need that data type. And I need their bio. I don't need the timestamp, but I need another string for their avatar URL so that we can render the user's profile. We'll get their name, their bio, and wallet is their primary ID and avatar URL. I think this is good. So now what I'm going to do is I'm going to create a mapping, and we're going to create a mapping from address to user, and it's going to be called users. I'm also thinking that in Twitter we have the concept of handle, and the Twitter handle, in fact, like instead of the wallet name we can also use a handle. So let me add a value here called string handle, and we can actually do this. Basically what we can do is map the address to the handle. So let me map it to the string handle, and we can create another mapping from handle to username. I'll explain why I'm doing this, but first let me just create the second mapping, string to user, which is actually users, and this is not users, this is usernames, right? So what we're going to do is we're going to take a mapping from address to string handle. Actually, let's just call this username just to be more specific. So name is their actual name, like my name is Abhi, and like my username could be my Twitter handle, and my wallet is my Ethereum wallet, and bio and avatar, right? So now what this will do is basically I want to be able to address both ways. In Solidity, there's no way to create a reverse mapping from an object. So how we're going to do this is we are going to map that Ethereum address to the username, which is supposed to be unique, and we will use this to sign up. And we will also create a reverse mapping because I want to also map from username to user, and I want to make sure that a username is not a duplicate of someone else's username, right? If I have if I have a mapping from this address to a username called Abhi, nothing is stopping someone else from also taking the username Abhi unless I validate that username Abhi is already taken. That's why I'm creating two different mappings. All right. So now we have these mappings. Now let's create a function, sign up, right? And this sign up function will take some arguments. It'll take name, username, bio, avatar. Yep, that's perfectly fine. But let me not call. I mean, we can just reuse this. This is, again, these suggestions are coming from my GitHub Copilot, but this is not the best way to do it. I will get rid of the function body for now. I'll leave the last part because I am in fact setting users and usernames. But what I'm going to do here is I'm going to create a user here, right? So this is how you instantiate a user. The other way is just you create a user and then set each of its fields, or you can just instantiate the user at once and set up all its fields here. So if I can set up the wallet name from message sender, and I can take the name from this argument, username from here, actually, yeah, username from here, bio. Let me put the username first because that is going to be the unique address. And I take the string bio and string avatar, right? What I can also do, what I actually need to do is I need to give them all the type memory, otherwise compiler is going to complain. So these are all memory variables, and but before we actually set these things, we need to verify certain things. So we will set up some constraints here, right? So we'll do a require, and we will check that first mapping is usernames of underscore of message.sender. We just want to make sure that let me just take the message here saying user already exists, right? But how we're going to check that is, so in Solidity, this mapping is created, and it is in a way that all addresses will have some value. They will not, there's no concept of null or undefined values in Solidity. So we need to actually get this value, and we need to check if there is anything there. So I'll just convert it to bytes. This I think is the best way right now, but if you have some better way, you let me know, let everyone know, and we can improve that from there. But for now, this will work. I think if I just do bytes of this, dot length equal to 0, right? This means that this condition is required, and if this condition fails, an error will be thrown, and the error message will be this: user already exists, right? And we can test this. So let me write a test for this. Yeah, here let's just get rid of all of this. Yeah, so we have deployed the contract now, and now we can actually start testing it. All right, so here we're going to sign up the user. So let me do await Twitter dot sign up, and I need to send three parameters. Let me just quickly check what we're sending: username, name, bio, and avatar. So 4 parameters. Username is Abhi, name is Abhi, and bio is some bio, and avatar URL is some URL, right? So this is how I'm signing up for Twitter now. And what I'm going to do is now actually log this so that we know what's going on. Signing up user for, right? And after this, we will just check that expect await Twitter dot get. Actually, it's not get username, because we have just written a function usernames, and but this won't work because usernames again is a mapping from address to username, but we need to check if username exists. So what I can actually do is I can actually just check that users of key, but it will not return the string, right? It will return the object. Let me get the address. So how to get this address is basically here we can do const user is await ethers.get signers. What this will give me is the user who is actually executing this message. In our live web app, it will be the user who is the Ethereum wallet. And here what I can do is take user.address, and there I can check that this username would be Abhi. So let me try and run this test. Let me first compile this contract. Oops. So this is a problem because we are currently in the Twitter directory, and I'm supposed to be in the DApp contract directory of Twitter, but I have it somewhere. Yeah, here it is. Let me compile this. Okay, there's some issue. This says users of message.sender. Type address is not convertible to string type memory. Okay, so what I'm doing wrong here is I'm setting usernames correctly, but users is the string type username. So I have to set this to underscore username, because again, username, the first part is address. So that address mapping is correct, but in this users, the first part is the string, which is the username of the user. Now let's compile it again. All right, so now the compilation is finished. Now we'll run the tests. Okay, it should return the name. So it is returning, and let me just rename that test. Test Twitter sign up flow, right? So basically I want to test my error that is thrown here with require, right? So if the users already exist, and basically if that person calls sign up method again, this error should be raised. So I can just call that. Let me do await expect Twitter dot sign up and give it some values. We can give empty values for now because we are just testing that it correctly fails. right? And to be reverted with user already exists, right? Let me run this test. Yep. So, and let me also log this. Test user already exists error, right? And just to show you, this is the correct error message, but if I just add some character here, and I'll show you that this test works, right? So this test failed because expected transaction to be reverted with user already exists. This is what I'm expecting, but it returns user already exists, right? So we want to test that it is returning the exact error that we want it to return, right? So if I go here, I'm sending user already exists. So this is what will be returned here, and this is what we are testing in this. So this helps us confirm that the user can only sign up once, but still some other user can actually sign up with their name, right? So actually, let me write that test for this. So this is user. Actually, we can take multiple users here. Let me just take this user. Okay, so this user is used somewhere here, right? So we can call this user one, right? And I can take one more user here. So this get signers method returns all our signers. So if you look at this, right? So we got so many accounts here. My get signer method will return all these accounts. So this is in theory an array of all these users. So if I do dot users, this users array will have the addresses of all these accounts, right? I don't need these though. I just need two users for now. So let me use two users, and I'll do this exact same thing again, but I'll do it with the other user. Okay, so let me do that. Um, and I want it to fail, right? So I'm going to retry this part, right? And what we're going to do is twitter.signup. But before this, I want to sign up as other user, right? So I can do twitter.connect, and I can give it user2 dot sign up this to be reverted with user already exists. No, actually this needs to be reverted with username is taken. Um, please try another one, right? So now I will run the test. It will fail because currently, okay, let me pass the exact same thing. Username is Abhi. This is some other person, and it has some other bio, and they have some avatar. All right. This, in theory, this person is trying to take my Twitter handle, which I've already taken, and it should fail, right? But let me run this test. Transaction, I'm expecting the transaction to be reverted, but transaction is not reverted. This means that my validation is failing. So what I will do here is I will add another require statement, and I will test that users of username dot wallet equal to zero will not work. I'll show you that. Let me just show you that. Let me copy that exact error message that we wrote. Username is taken. Please try another one. Right? But here, this will not be zero. Let me show you this because the data type is different, right? The data type is address, but let me run this. The compilation will fail here because my data type is not correct. Look. So what I'm going to do here is this wallet is address of zero. So address of zero basically means that it's a null address, right? In Ethereum, in Solidity, there's this address of zero, and the value of that Ethereum address is something like 0x000000. That's the first address on the Ethereum's blockchain. So usually it is used in a way where, you know how people burn their tokens. Like when Ethereum is getting burnt, all that burnt token is sent to this 0x00 wallet, which means that that wallet is, nobody can access that wallet because nobody has the private key of that wallet. So all the burnt tokens go to 0x00, and this is how we will check that that is also the default address, right? So I explained to you that in Solidity these mappings all of the keys are actually present in the mapping. You can assume that the keys are present because the hash table implementation is such that all the keys are actually present by default. The only difference is that they are initialized with their default values. So if my value here, the key is string, and the value is integer, it will be initialized to 0. If it's a string, it will be initialized to empty string. That's what I'm checking here. This bytes length, this is the length of that string. I'm checking that it's 0, which means that it's an empty string. I cannot directly compare it to an empty string because it would throw an error, right? But this should now work. So let's try this. Okay, it failed again. Did you mean, and oh yeah, I meant this is underscore username. Right, let me run this again. Yep, that works. Test user. Okay, I'm logging the incorrect message on the second test. Let me, username is taken, test. This is user name is taken error, right? So let me again show you that this test is working. So here I was expecting it to say username is taken something, and it actually said username is taken, please try another one, right? So this is why we need to give the exact error message to test that this transaction will be reverted by saying username is taken because this person used the same username. On the other hand, if I actually use a different username, then that should go through, right? Because second person should be able to sign up with their username. And so here I expected the transaction to be reverted, but it was not reverted, right? Which is correct behavior. So this is perfect. Now what we want to do is we want to test that the user object is also created. So we will test this user object, but before that, actually, yeah, let me just write the test for the user object. So here I can somewhere, yeah, just right here, let me get const user is Twitter. I'll have to await this, right? Await Twitter dot users of Abhi, right? So this will give me my first user. Because I explained to you how we actually, if we declare a storage variable as public, Solidity will create a constructor for us, right? So with that constructor, I can get that user object, and then I can expect user dot name to equal Abhi. I can expect user dot bio is some bio. I can expect user dot URL is some URL, right? So let me log this also, console.log test sign up, or like, yeah, I'll just say test sign up is successful, right? So let me run this test. Undefined to equal some URL. So the URL is not being set. Okay, this is not URL, this is called avatar in our case. So that's the mistake. Let's run the test again. Yeah, so signing up the user Abhi, test sign up is successful, test user already exists error, test username is taken error. So now I know that I can get, if I give the, here if I give the user's address, I'm able to get the username. Here if I give the username, I'm able to get the user back. And after this, here I'm testing that if the same user tries to sign up again, it will throw this error, user already exists. If some other users try to sign up with the same name, same username, then it will throw an error that username is taken, right? So this is perfect sign up behavior. And what else do we need, right? Let me also create one utility function to actually give me the user object straight from the wallet, right? Because I think that will be useful. So let's create another function, get user from address wallet, and it returns the users of usernames of wallet, right? Because there's a mapping from username to user, but there's no direct mapping from address to user. So what this is doing is it is taking usernames of wallet address, which is the address that I've supplied, and that will give me the username, and it is getting the user object with that username, and it will return that user, right? Let me test this. It should fail because let's just test it. Yeah, see, it fails because it's not memory, right? So this user which is returned needs to be from memory. So let me just add memory here, and now it should be okay. Okay, so compilation succeeds, but let's also write a test for this function get user, right? So what I can do here is the same exact thing. I'll copy this, right? The only thing I will change is user. Let's call this user from something, right? User from address is twitter dot get user from address, and I will give this user one dot address, and it should give me the same user, and I will verify that all the things are correct. I'll also verify that expect dot username dot to equal abhi, right? So I just want to verify that this function works. So I'm passing it the address, and it should return to me this object where I can verify that my user is indeed Abhi, right? Let me run this test. Get user from address is not a function. What did I call it? Get user. Oh, okay. So I just called it get user, right? So let's test this. So I can get user from the Ethereum address, and I can get the user directly from the username, and this should help us. So I think this is a good stage for us to be with respect to the contract. And let's actually build this in our front end so that this whatever we have done on the test, which is the sign up flow, we will also do it from the web app. So yeah, let's do that. All right, thanks a lot for watching this video. I hope you liked this one. If it was helpful, please smash the like button, leave a comment down below if you have any other questions. You can also reach out to me on Instagram or Twitter. I'll leave my links in the description and on the screen. So yeah, looking forward to see you in the next one. Thanks for watching.